Alright, so when you're working with LEDs, you need to use a current limiting resistor so that you don't damage the LED. And most data sheets for LEDs don't tell you what resistance to use because they don't know what your power supply voltage is. So in this video, I'm going to tell you how to calculate this resistance to get the most brightness out of your LED based on the specs of the LED itself. Okay, so the only formula you'll need to know is Ohm's law, and this is voltage over I, which is current, times resistance. Okay, and I write it like this so that you can calculate any one of these three variables by simply putting your fingers over it. So if you wanted to calculate current, cover it up and then go V divided by R. If you needed to calculate resistance, you go V divided by current. If you needed to calculate voltage, it's current times resistance. So it's just an easy way to remember it. Okay, so let's start off with our circuit. So you have your power source here, you have your current limiting resistor, and you have your LED. Now remember, LEDs are polarized, and they kind of behave like diodes. Oh, and I should put those in. So you need to have your anode and your cathode lined up. So if your current's flowing down this way, basically, if you have your power source up here, that needs to go to your anode. You can think of it like your positive sign on like a battery. Okay, that's kind of the way these LEDs work. They don't work if you have this switched, and you can always tell. Let me show you. You can always tell which one's the cathode and anode by looking at the leads themselves. The short lead is the cathode, the long lead is the anode, and also, because sometimes I cut these to fit on my breadboard smoothly, so I don't know which one's short and long. You can look on the one side that has a flat little groove. It's flat on one side. That's the cathode. Okay. But let's finish our circuit here, and we have V. Okay, so here's how you do it. You have to look at the specs of the LED first, and you'll find something called forward voltage, or VF, usually. And you'll also find something like a forward current or maximum current of the LED. So you need those two specs to determine what the current limiting resistor should be. So let's just pick a pretty standard value for these LEDs, and that's about 2 volts is your forward voltage, and about, for your current, it's about 20 milliamps. Okay. Oh, and another thing, if you ever want to convert this milliamps into regular amps, just divide it by 1,000. So that's also equal to 0.02 amps. Okay. Alright, so basically what this forward voltage means that right here across that LED, you're going to have 2 volts. So if you have 2 volts there, get rid of this. If you have 2 volts right there, and then let's say we have 5 volts up here, then that means the difference here, 5 volts minus 2 volts, then that means this LED has a voltage drop of 3 volts, right? 5 minus 2 gives us 3 volts across there. So we know what now we're looking back at Ohm's law again. Now V over IR. We set this up. Okay, so we need to solve what R is. Do we have the current? Yes, we do, because the current in a series circuit is the same through each component, and we want it to be 20 milliamps, right? So our current is that 20 milliamps. Or just to make things easy, let's just make it the 0.02 amps. Okay? So to solve for R, we take, crap, I got a good calculator. We go 3 divided by 0.02, and that gives us 150. 150 ohms. So if we use a resistance at 150 ohms, we would be giving this LED its maximum, it would be at its maximum power, which isn't really a good idea. You'd probably want to go at least 10% higher than that, or the next resistor size in your bin, so that you don't really burn this thing out, because you don't really want to operate it at its maximum conditions. So let's see. I mean, that's 0.1. Yes, I mean, I guess like maybe a 200 ohm resistor for this application would work. You always see 330 ohm resistors in a lot of these types of circuits, but that's basically how to calculate the resistance. If you're in a jam, let's say suddenly this changes up here to 12 volts and you're working in your car and you want to turn an LED. It's the same thing. You go 12 minus 2, which changes this value up here to 10 volts. Okay? Current stays the same. We always want, that's why they call it a current limiting resistor, because we need to limit the current here through the circuit to 20 milliamps at all times. Okay, so if we went 10 divided by 0.02, that gives us 500 ohms. Okay, so it went from 150 to 500 just by switching it from 5 volts to 12 volts. Okay, and also you can use this whole formula here to find out if you are using the right resistance. Like, you might have noticed in all my videos, practically every video, every project I use a 1K ohm resistor. Just because I have a million of them, I don't feel like digging through everything trying to find a 330 ohm or a 150 ohm. So let's say we have 5 volts. Now this is actually the same circuit I had up here with a 1K. So our forward voltage is 2 volts. So if we build it, we have 3 volts. Our resistance is 1K. And let's find out what the current is in this circuit. Let's see how much lower I am than 20 milliamps. Okay, so if we went 3 divided by 1K, that gives us 3 milliamps. So I'm much lower than 20 milliamps in this circuit here. But it gives me decent brightness. So I always start with a 1K, because I'm definitely never going to blow the resistor at 1K, or I mean blow the LED. So it's a good place to start, and then you can work your way down. And by the way, 1K ohm is 1,000 ohms. Okay, so it's all scientific notation. I might make a video on that too. How to get from kilo to mega to giga to milli to nano to pico. We might talk about that in a future video. But for now, I hope this helps you figure out what resistance to use in your LED applications. Thanks for watching.